Hello, this is Mrs. Brookshire. We are going to be studying section 1-3. This is part 1, and then there's going to be a part 2. So the last section dealt with displaying quantitative data with graphs. So this section is still dealing with quantitative data, but we're going to be describing quantitative data with numbers and with statistical measures. So I think that when I say, what are some statistical measures you've heard of before, probably in middle school you study mean, median, mode, range, and those are statistical measures. So today we're going to talk about the measures of center. We're going to talk about how to compare the measures of center and which one is the best representation of the data. And we're going to talk about measures of variability. So the definition of mean, if I were to ask you what the mean is, most of you guys would say, if I say, how do you find the mean of 10 scores, you would say, oh, you would just add them all up and it's the average. So that's the definition. The mean of a distribution of quantitative data is the average of all the individual data values. To find the mean, add all the values and divide by the total number of the values. So if you have n observations, that's how many, x of 1, x of 2, up to the nth, x of n terms, the way you find the sample mean, which this is the symbol for sample mean. It's x called x bar, and it's given by the following formula. So it does just tell you what to do. Sum of the data divided by the number of the data. And so this is what you would see on the formula sheet. This is the Greek letter sigma, and sigma means sum. So what this is telling you in this formula is you want to find the sum of all the values and then divide by the number of values. This formula is on the formula sheet. I'm going to show that to you. So on your formula sheet, descriptive statistics, x bar is equal to, and that's the sum of all the x values, or all your values divided by the number, or there's the sum multiplied by 1 over n. So we're going to talk about that today, and then the other formula we're going to talk about is your standard deviation formula, which is also on here. A lot of times these values you can just, they may not ask you to find, or you could use a calculator to find. But a lot of times they just want you to explain what it means, especially standard deviation. So I'll just show you real quick. There's a technology. You could just add and divide by how many. So let's say we had 10 students in AP Stat, and I wanted to take the average of the, the first test. So what I could do is I could hit stat and edit. I could list my test scores. So I told you there were 10 of them. And so instead of just adding all and divide it by 10, if you put them in list 1 and then you go to stat, go over to calc and do one various statistics. So it was stat, calc, one various statistics. It will give you, there's x bar, there's your mean. And then that's the sum of your x's. And then this is your standard deviation. It also gives you the 5-number summary, which we'll be talking about in part 2. So it does give you a lot of the data, and it says, okay, there's 10. And so anyway, that's another way that you can find the mean by putting it in the calculator, and you find a lot of other values as well. Okay, so we need to talk about a couple of definitions. So the first one is, what is a statistic? A statistic is a number that describes a characteristic of a sample. So you guys fill in the blanks here. A parameter is a number that describes the characteristics of a population. Okay, and so an easy way to remember this is the S's are together. Statistic describes a sample or a characteristic of a sample, and a parameter describes a characteristic or a statistical measure of a population. I will tell you that with a parameter, they always use Greek letters. So I'm going to give you an example here. So here's our example. We talked about what X bar is the sample, or mean of a sample. Mean of a sample. Okay, so most of the time when you have data, it's not the true population, but it's a sample. So if I had to find, this is mu, mu, and that's a Greek letter, and this is going to be the mean of the population. So I did want to point out that you need to be really careful with the notation you use, because if you're on the AP exam, you use the wrong notation, they do take points off. So X bar would be the mean of your sample, and mu, which is a Greek letter, would be the mean of the population. Okay? So that's the difference between a statistic and a parameter. Statistic is a statistical measure of a sample. Parameter is a number that describes a characteristic of a population. Okay, now a statistical measure is resistant. So fill that blank in. If it isn't sensitive to extreme values. Well, extreme values are like outliers, okay? So when you think of resistant, like resistant to you probably means, doesn't want to change. And so that's kind of what, when you have a statistical measure that's resistant, it doesn't want to change, okay? All right, so I'm going to give you an example. We're going to talk about mean versus median. One of them is resistant and one of them is non-resistant, okay? So when you look at this distribution, which is goal scored, okay, what way is this distribution skewed? The distribution is skewed, so when you look at it, it's obviously skewed to the right, okay? So it's skewed right because that tail is over here on the right. Should we use the mean or should we use the median as a measure of center? Okay, well, I'm going to tell you that the mean is right here. It's 3.14. It tells you the mean is 3.15. So we know the mean is 3.15. So we're going to talk about the median, which I'm not sure if you remember how to calculate the median, but the median is the middle term or the midpoint. So it says, should we use the mean or should we use the median? And without using data calculate, how can we determine if the mean is greater or less than the median? All right, so I will tell you that if you have a distribution that's skewed like this, I want you to think, what's going to change? Okay, if you have a symmetrical distribution, I'm just going to tell you the mean and the median are approximately the same. But if you have if you had a skewed distribution, which one of those two statistical measures changes? The median or the mean? Okay, so don't forget mean is you add them all up. So think about this, if you're adding in these outliers, obviously it's going to make the mean be larger. It's going to move it in that direction. Whereas the median is going to stay about where it is. It's going to stay where it's at. Okay? So should we use the mean or should we use the median? We should use, and sometimes you have to make that choice. Like if you're describing a distribution and they ask you to, what's the best measure of center, or what's the center, you got to decide, should I use median, should I use mean? On this one, you should use the median because there are outliers. These up here are outliers, those values. There are outliers. And that's the word resistant. A median is resistant. Okay? Because if you do have outliers, it's not going to change it. But if you have outliers and you're finding an average, obviously that's going to change it. Without using the data, can we determine the shape if the mean is greater or less than the median? Well, obviously, we just talked about that. The mean on this one would be greater than the median. Outliers pull mean in their direction. So outliers pull the mean in their direction. So we can go back up here to the definition of resistant, and we can say that median is resistant, mean is non-resistant. So a median isn't going to change or doesn't want to change with outliers, and that's the definition of resistant. Isn't sensitive to extreme values, but a mean is sensitive, so it would be non-resistant. Okay, we're going to talk now about how do you find the median. So I'm going to kind of review. The median is the midpoint of a distribution, the number such that about half the observations are smaller and about half are larger. The way to find a median is to arrange the data values from smallest to largest. If the number of n values is odd, so if you have an odd number of values, the median is the middle value of the ordered list. If the number of n values, data values is even, you average the two middle values. So hopefully you remember how to find the median. I am going to remind you, so the median is easy to find by hand for small sets of data. If you have a big set of data, you probably want to put it in the calculator, especially if you find some other things, because it will tell you the median. For instance, here are the data from the highway fuel economy ratings for a sample of 25 model year 2018 Toyota 4Runners tested by the EPA. So the first thing you have to do, so here they are, you have to start by sorting the data from smallest to largest. Okay, so it does say that there's 25, so n is 25. That's an odd number. So that means there's going to be one middle term. You got to put them in order first. Now this is probably how you did it in middle school. You went through and you said, okay, smallest, largest, small, large, and you just keep going in until you reach the middle value. Remember, there's going to be one middle value. So let me tell you an easy way. What I do is I take 25 and divide by 2 to get the middle, which is going to be 12.5, correct? Okay, so you're like, well, how do you find the 12.5 term? You round that up, and the 13th term will be the median. So anytime I find the median, I just take the number, divide by 2. If it's a decimal, because it's odd, then you round up, and it's the 13th term. So then you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's the 13th term. So that would be the median. 22.4 would be the median. Now, if you went through your old method and you just did the mark out thing, that would be your middle term. So this is just a little bit quicker. Okay, so now let's find the median from an even number of values. Well, the first thing you have to do is you have to put them in order. So you're going to count how many ones there are. And I believe there are 6. So we're going to write 1, 1, 1, 1, 1, 1. And a lot of times people will go through and just kind of put them in order and mark them off. 1, 2, 3, 4, 5, 6. Okay, how many 2s are there? There's 1, 2, 3, 4, 5. So 5 2s. There are 3 3s. There's a 4. And there's 5 5 5, 3 5s. And there's a 9 and there's a 10. Okay, now I have them in order. So on this one, there are n is 20. N is always the number of elements. All right, now, so we talked about the measures of center, mean and median. Now we're going to talk of the measures of variability. So the 3 measures of variability we're going to talk about are the range, the standard deviation, and some of this is going to carry over to the next, to part 2 as well. The IQR, okay, interquartile range. Some of you guys might remember that from an earlier math course, interquartile range. So we're going to talk about that. So range, the way you find the range is it is the maximum minus the minimum. The maximum value, maximum minus the minimum. Now let me tell you, like if they ever ask you for the range, the range is actually a single number. Okay, so that is a single number, so you do want to do the math and you want to subtract. The IQR the way you find the IQRs, we're going to find something called Q3, which is quartile 3 minus quartile 1. Okay, we'll talk a lot more about that in the next part. Okay, so these are the three measures of variability. So think about range. What is range? Well, you're taking your highest value minus your lowest value. So that's variability. That's the variation between the high and the low end. Okay, standard deviation, you know, the way I like to think about standard deviation is it is the typical distance away from the mean. Typical distance away from the mean. Okay, so that's a real clear, I think, explanation of what standard deviation is when you find that. What is that number? Because it's a number. All of these are numbers. That's a number, that's going to be a number, and that's going to be a number. Okay, so the range. Do you think the range is resistant or non-resistant? The range is non-resistant. Think about it. It will change. If you have outliers, it's going to change. Okay, it's very affected by the highest and the lowest. The IQR, these two things are not affected by the highest and the lower, so this would be a resistant measure of spread. Okay, we're going to go through and we're going to find the standard deviation. How do you do it? Okay, I'm going to tell you most of the time you're not going to do this. You're just going to find it on the calculator, and you're going to be asked to interpret it more than anything. All right, so 11 high school students were asked how many close friends they have. Here are their responses along with the dot plot. So they were asked, how many close friends do you have? There's their responses. Okay, so N is, it says 11. So there's 11 people that were asked. Okay, so this is how you go through and you find the standard deviation. The first thing you're going to do, if you had to do it by hand, is you need to find the mean. The mean is important. It's part of the problem. So you would go through and you would calculate the mean. So that would be 14. When you go through and you add all these up and divide by 11, you will end up with, let's see, it adds up to be 33 divided by 11. So our mean of this data is actually 3. 33 divided by 3, okay? So if you were doing this by hand, you would list all the values. So you've got 1, 2, 2, 2, 3, 3, 3, 3, 4, 4, 6, or 4, 4, and 6. Okay, so I'm just doing what it says. The next thing we're going to do is we're going to take each value and subtract the mean. So we're going to do 1 minus 3, 2 minus 3, 2 minus 3, 2 minus 3, 3 minus 3, 3 minus 3, 3 minus 3, 3 minus 3, 4 minus 3, 4 minus 3, and 6 minus 3. Okay, so the next thing we're going to do is we're going to find that difference and we're going to square it. So if you think about it, you know, the distance from the mean, so you are finding the distance from the mean. But what happens is sometimes if you have these negative values, they're going to cancel out with like any of the positive values. So you're not, that's why they have to, well, we're going to square those values. Okay, so negative 1 squared, negative 1 squared, negative 1 squared, 0 squared, 0 squared, 0 squared, 0 squared, 1 squared, 1 squared, and then 3 squared, which is 9. Okay, now we're going to go and we're going to actually add all those up. We're going to find the sum, and that equals 18. 9, 10, 11, 12, 13, 14, 18. Okay, so if you look at the formula for standard deviation, well, let me tell you first, let's go and write down these two symbols. So this is, that stands for the variance, and the standard deviation is the square root of the variance. So if S squared is variance, the S sub x is the standard deviation. So what we're basically doing is finding the variance and then taking the square root, okay? So to find the variance, you're basically finding what we just did, and then we're going to divide by n minus 1. So that's equal to, we found that was 18, the sum, and then 11 minus 1 is 10. So that's equal to 1.8. Okay, so that would be our variance. And then our standard deviation is going to be the square root of that. And that's equal to 1.34 if you put it in the calculator. Okay, so if you had to do it by hand, that's how you would go through and find the standard deviation. Now, technology can be used by going and finding, like if we did the standard deviation of the test, we already have the data in there from earlier. So you'd go to calculate various statistics. Whoops. And there is your standard deviation right there, 12.2. Like that was for some data I had put in there earlier. So that's another thing you could do. Instead of going through all of this, they hardly ever ask you to do that. More than likely, they would just say, you know, what does this mean? What is the interpretation of this? So if I were to ask, what does 1.34 mean? It means that you got to put it in context. 11 high school students were asked how many close friends they have. Here are the responses. So you would say, if I ask you to put this in context, you would say high school students, number of friends, number of close friends. That, as I said, to interpret the standard deviation. High school students' number of close friends is 1.34 from the mean of 3. Okay, so high school students' number of close friends is typically 1.34 from the mean of 3. So that's what that standard deviation would be. All right, that was part 1. So we're gonna work on part 2 coming up.